Well, we'll be ready to see that again. Just get it ready for the next one. Okay. I'm going to go ahead and mute some people. You can unmute yourself anytime. Welcome to the second Propeller 2 Live Forum of today. Spin 2 Beginner Series with JonnyMac. We're working with XBees today. I'm just curious who all has them. Maybe you could put in the chat if you've got the hardware in front of you. I know at least half a dozen people do. So this is really, really exciting. John has already posted the code for today in this forum thread, and I will paste it into the chat right now if you want to go get that. Thanks, John, for being ahead of us. This is great.
Ken, I just posted the links to the direct post and to Digi for XCTU. It's in, those are in the chat.
Wonderful, wonderful. And before we turn this over to John formally, we want John to keep working for all of us like he's doing so well. So I'm going to head over here and make a deposit at the Bank of JonnyMac. And when you do this, make sure you note it as a gift, because PayPal gets really scrunched up and protective of your money if you don't call it a gift. So just call it a gift if you put your copy their money for John. So I'll copy that link in just a few minutes. John, I'll turn over to you then.
Okay. Hi, everybody. I guess we don't need to see anything on my screen right now. Today we're going to be talking about XBees, and it's going to be really a small portion of this huge world that is XBees. You know, over the last couple of weeks, as getting back into it and trying to figure out what I was going to do, I remembered how involved XBees are. So we're going to do a very tiny bit of it. I'm not going to lie to you, today will seem a little bit hairy at times. So we're going to go very slow. I've been under the weather for a week anyway, so I'm already slowed down. That may be a good thing since I tend to speed up. But we will go slowly. If you have questions, just shout them out, because there's enough details that I don't want anybody to get left behind. Couple of things. I posted the files for today in the link that's in there as regular archives, like you're normally going to find, so that we get used to the idea of getting an archive from somebody. So if you've not been through this, if you're new to the propeller stuff and you get an archive from somebody, what that archive is going to have is the application and all the libraries that are required for it. So unzip it, and the file that has the same name as the archive without the date and time information, that's the main application. You can put that wherever you want. All the other spin files you'll want to put in your library, and make sure that to let it overwrite so that you have whatever my latest is. I've made a couple of adjustments lately. So let them overwrite. The other thing too is you may, for example, I was playing with wave stuff recently and I haven't posted any of those files yet, but if you get files that are not spin, put them with the main application. So for example, you might have a bitmap file. I know Stephen has been doing stuff with his panels, and he can take a bitmap file and display it. The bitmap file you want to put with your application. So I just want people to get used to the idea of how to deal with a library folder. I see this question come up with newcomers a lot. And I thought, well, I was running a little late today, so I thought, well, let's just do this the way that people are going to get their files normally anyway. You will need XCTU. You don't have to have it today, frankly, but when you want to deal with your XBees, because you need that to do the initial configuration. Once we have them configured for a particular mode, the propeller can actually adjust parameters inside the XBee. And I'll talk about some real world experiences. One of the things I sincerely try to do is not talk all theory. You know, I'm lucky that I work in a weird industry, and and it is loosely connected to other weird industries. So I have these opportunities to do real world things. So I'm not suggesting that any of the things that I've done with XBee are monstrously sophisticated, but they're working in commercial applications. So I try to do things that are straightforward, that are easy to replicate and easy to test. So questions to start with?
Just a comment, John. Anytime you want
Yeah.
to take a 2-3 minute break, get some water, rest, we're right behind you.
I have a big water jug with me today.
All right. Don't be afraid to pause anytime, because
Okay.
I know people will also be wiring and things like that to get caught up.
Yeah. Yeah. So now, if what I was trying to do too, because I had some code and I thought, oh, I don't want to change to parts we haven't already used. So for those that are really good, like Steven, I'm going to pick on him because he just did a great presentation that I missed most of. If you have your encoder handy, then you can use that. I've already got mine hooked up. So you'll see that I think it's program 3. Yeah, it is program 3 of the programs we have. Notice there's not a lot of programs today. It's because this stuff's hairy, so one's enough. We are going to go into the object a little bit. I'm going to treat the XBee object that I use for the API mode a little bit of a black box, but I want to show you what's happening in case you want to extend it. It's fairly straightforward. Again, I've used this in commercial applications and it works fine. But as ever, I'm open to sincere criticism. That is, if you say to me, hey, JonnyMac, I think you might want to consider this idea, I absolutely will. I'm always looking to make my code better. In fact, so, since that direction from my home is the Disney studio and George Lucas now works there because that's where Lucasfilm is. George Lucas says that movies are never finished. They're just abandoned. And I feel that way about software. We never finish it. We just say, okay, I've had enough and I'm not going to change it anymore. With libraries, I'm constantly going in and making tweaks. So I'll go ahead and share my screen, Ken, if that's all right.
Of course, John.
Find the button.
Bottom, middle,
Yep.
Missing toolbar.
And share, and then we'll go over to the previews of things to come. Okay, we are doing spin 2 again. And this week, we're doing an introduction to XBee. I actually had this titled Easy XBee, and then about 2 hours ago, I changed it because some of the things, they're not, I don't want to scare anybody. They're not hard, but they're involved. So there's lots and lots of details. But once you have all the details sorted out, it works really nicely and it's fun. So we talk about XBee. XBee is a wireless communications module made by a company called Digi. And now the way we're going to be configuring the Series 3 module is to behave like the old Series 1 module. That way all my back code will work. And so they're running 2.4 gigahertz wireless communications. If that sounds familiar, it's in the same general range as your Wi-Fi stuff, your 2.4 gigahertz Wi-Fi. We're going to talk about that in just a second. XBee uses a protocol called 802.15.4, and it is useful for point-to-point or point-to-multipoint, a full-on network, and we can configure in different ways. Now, again, there's lots and lots of stuff going on with XBee, especially with the Series 3 modules. The Series 3 modules have all kinds of new stuff. Bluetooth, there's MicroPython is built into them. There's a lot of stuff to be explored. Again, for the purposes of today's presentation, I'm going to treat them like a Series 1 module. So if you have a Series 1 module or even a Series 2 module that you can reprogram in the same way, you can follow along today. Today, we're not doing anything that is code specific or feature specific, I should say, to the Series 3 module. So where we typically start in the XBee world when we're experimenting is what's called transparent mode. And in this mode, we're going to use XCTU to set up 2 modules so that they're in the same network. We'll talk about that more in a bit. And they're pointing at each other. The general idea is we're going to use this to replace a wired connection. Now, there is a caveat there. Wires are directly connected and signals go right now. We have some intermediate processing going on within the XBee, so there's a little bit of a delay. I ran into this and I was scratching my head thinking, why is that signal not there already? And I was talking to Ken yesterday. He was reminding me to take more breaks, get up away from my desk. And I did one of those and went out for a walk, and it dawned on me, oh yeah, we're sending a message from the propeller into the XBee that's, you know, there's a small serial stream. Well, the XBee is doing a lot of things underneath to convert that stuff that we send to a properly formatted message that works in the 802.15.4 network. It has to go across the network, be pulled apart, if you will, and then represented out the other end as if it was a wired connection. So there's a bit of a delay in there. So just be mindful of that. It's not normally problematic, but know about it so that you can know how to deal with it. The other modes that are available are API mode. Now, I think everyone knows API stands for Application Programming Interface. There are a couple of modes and kind of enhancement to those. I'm going to use API 1. Now, API 1 is a packeted mode, so we're going to create the packets. API mode 2 is about the same, but it has escape sequences built into the packet, so that the idea is that if you have the value that is the header byte of the of a normal API packet in the packet, it won't create a problem. To be candid with you, I've never found an issue with this, but it could be the way that I'm processing packets, and I'll show you that in just a moment. So we're going to use API modes for the real kind of networky stuff. And this is where, you know, API mode is useful. We want to have a master controller talking to a bunch of devices. They can, in fact, talk to each other as well. My biggest experience with lots of XBees on the same system and working together is lasertag. I've mentioned doing lasertag a number of times. And in the lasertag product, there is XBee radios that allow the taggers, we call them, we don't call them guns, we call them taggers, can communicate with each other, and they can also be commanded from a master controller. And if you're wondering, well, geez, why do the taggers need to talk to each other? Well, for example, if you're 500 feet from somebody and you score against them, you may not see the visual indicator. The players wear these hats and have lights on the hats. You may not see that. But what will happen is the tagger will send a message to you that says, hey, that's a good hit, or you've defeated that person, which means they have to go back to their base and deal with it. So there's different messages in there. The interesting thing is that in the laser tag, the way this works full circle is the laser bullet is an IR packet, which we'll talk about in another session. The IR packet contains the address of the shooter, if you will. And then when whatever happens, whether it's just a hit or it's a defeat on the victim side, they put together an appropriate message, and since they know the address of the shooter, they can send it back. So it works very nicely. And then there are global messages too in that system. The company that I work with, they're now called Elite Laser Tag. So if you're interested in laser tag, look them up. They're all great people and they make really nice stuff, and they're all propeller powered. But they're really involved in youth groups and that, because kids are, they love to compete, and they want to do this stuff outside, sometimes in the woods or just a park or those kinds of places. And you don't want to drag a computer out to keep score. So there is a mechanism for the taggers to keep score. And so in that mode, when a tagger gets hit, when there's either a score or a defeat, the tagger actually broadcasts a global message to all of the taggers. So I can say, hey, I'm JonnyMac, Ken just got me. And all the taggers now log that into their internal mechanisms and keep track of the score. So it's a neat thing to do. We'll cover how to do these things in the course of the experiments today. But any questions so far? Oh, sorry, there is one last. I'll save it to the end. There's another API mode that's kind of neat that yeah, I'll share. One of my Hollywood friends needed some assistance, and we used a special XBee mode. So I'll show you that in the end. Everybody okay? All right, so we talked about the frequency used by XBee. It is the 2.4 gigahertz. So this chart, this information was actually sent to me by tech support at Digi. Because the environment is increasingly filled with more and more RF, especially with Wi-Fi, and those, we are competing with that space. Now, the Wi-Fi is a spread spectrum kind of technology, so is XBee to a degree, but you'll notice that the channels used in XBee are far narrower than this is the Wi-Fi down here. So the suggestion was from Digi, if you don't know what else is going on in your environment, you know, use channel F or channel 20. These are hex values here because you'll notice that those fall in between these non-overlapping Wi-Fi channels. Now, I know I don't do this religiously, and there are tools built within XCTU that can help us understand what's going on in our environment. So we'll have a look at that. But just be aware that we are competing for RF space. Right. In an XBee network, the module that we have is going to be assigned to a channel. We were just talking about channels here. And there is another organizational mechanism within the XBee configuration called the PAN ID. It stands for Personal Area Network. So you may have a bunch of XBees on the same channel that have different PAN IDs. Now, the groups will have PAN IDs. So all of these XBees are using this channel, but there is this PAN ID value. So these two XBees can communicate with each other. These three XBees can communicate with each other. These and these can't talk to each other. This PAN ID separates them. Right, so it's an organizational structure. The nice thing is all of this is down, you know, all of this is dealt with at, you know, under the hood, if you will. The nice thing for us is that we get serial packets out of the XBee, and we can tell if it was a message that came from a specific device. Sorry, it was a message that came to us specifically, or if it was a global message. For example, if you have you may have a command and control system that if a message comes from a single point, you will respond to that single point. Or sorry, forgive me. If the message comes and it's targeting you, so you know your individual address, because each of these modules have an address too. So there's kind of three layers. We have the channel, the PAN, and then there's an address called my address in the XBee. If a message is targeted at a specific device, you may want to respond back. If it's a broadcast message, though, that is all of the XBees in the PAN are getting that message, you may not want to respond. Otherwise, you'd just have a bunch of traffic going out simultaneously. Now, you can handle that in the XBees. I found out the hard way through a lot of kind of crazy work with the laser tag. Underneath the 802.15.4 protocol, there's a lot of negotiating going on. The XBees will check the channels, see if it's busy, and that way you can prevent collisions. And so a true story, with the laser tag, the original owner, who is no longer part of the company, he was an interesting character. And one of my many failures in life was not being able to convince him that despite the amazing nature of the Propeller 1, it was never going to give him the capabilities that Call of Duty on his big giant PC gave him. But he always was trying. And so, for example, he did this test one day where he lined up 10 taggers on a table, and then he had another tagger, and he shot all 10 taggers simultaneously, expecting to get back 10 hits. Initially, we didn't. We figured out how to get that. We had to add some randomization in the response stuff, and we had to increase some buffer sizing, but we ultimately did get there. And then I asked him, I said, you show me a game where 10 people stack up and I can hit them all with one shot. I'm going to go play that game and win every time. You know, it was one of those kind of things. He was the client, so I couldn't do anything about it, but it was a nonsensical kind of request that we fulfilled. But I learned a little bit about, you know, some of the XBee stuff and how well it works underneath. Any questions so far? It's a quiet group. I shouldn't have said it was going to be hard.
Oh, they're all chatting away, following along, setting up XCTU.
Oh, okay. Oh, good. Okay, that's right. Yeah.
I have a question.
Yes, sir.
So what these XBee modules do is they're actually handling like packet retry and maybe error correction in the background for you. So you're getting a lot of distilled information that you don't have to second guess, right?
Exactly. Yeah. If you get a packet through, you can almost guarantee it's good. Now, in an interesting thing that happened with the original laser tag, which is built on a PIC, there is a process in the laser tag called cloning, where a referee tagger, so it's running referee code, it can download a new weapon, if you will, to your tagger. It's called cloning. So we're just sending all those parameters, and it's a bigger packet than the laser tag stuff normally deals with. With the PIC-based product, they had lots and lots of troubles with RF cloning. In fact, they disabled it because it was so problematic. When I recoded it with the Propeller, we didn't have any problems at all. And I think there was two reasons for that. First, we had more horsepower. And one of the things that I did was I took the clone packet and I added an internal checksum to that. That packet gets put into the XBee packet, which also has all the protections from the XBee module, and it goes out. The other thing then is, you know, we had the two-step process. Once we got the packet, the clone packet from XBee, then I could pull apart the internal packet and verify the checksum on the other end. If it was good, we would update the tagger. We never had any problems with that. And what there was, again, of the interesting stories of that crazy 2-year project, because the propellers are so precise, again, same owner was doing a demo, and he said, watch, I'm going to clone all these taggers at once, because you could do a group clone. And he laid them all out on the table, did the clone command, the RF clone command, and when the tagger finishes cloning, there is a nice lady's voice comes, says cloning complete. And when they did that, they only heard one voice. They didn't think everybody updated because there was not enough separation between the audio on each for them to detect the different devices. So I actually had to add to that feature to turn on the backlight of the LCD so that you had a visual verification that the cloning happened. Once we did that, it said cloning complete, and all the lights were on at the same time. And they were just blown away by the precision of the Propeller. And again, worked really well.
Hey, John.
Yes.
This is something I get excited about. You know, with PCs, we've become accustomed to all these delays that have to do with garbage cleanup and all this stuff going on in the background. But when you have a very simple machine, it just does exactly what you program it to do. So suddenly it's like magic. Everything's happening lickety split, you know, and it's a different kind of thing, but it's a fun thing to work with because it's how things should be, you know, but we've become very accustomed to things kind of just hobbling along in a broken, compromised state. We've gotten to the point where we think, oh, that's normal.
Well, you know, again, that RF cloning was a very big deal for the laser tag company because when it didn't work, it would brick the device, and they would have to take it back and do a hard program change in it. And we didn't have that problem with RF cloning, so they were very, very happy about it. It made it easy because then later when a game management system comes along, you can send a clone packet from the base station and update all the taggers. So it worked really nicely. Again, I think a tribute to how well the XBee works, and perhaps a tiny bit to me being super cautious and making sure there were several layers of protection so that, you know, if any bit got out of whack, we could detect it and not create a problem for the tagger. So Ken just made a comment about XCTU. That stands for XBee Configuration and Test Utility. So we will need this to do our initial tagger configuration, especially if you have the Series 3 modules, because they have to be, you know, recoded, if you will, to run, to behave like the Series 1 module. So I have XCTU running with a couple of devices. Can everybody see my XCTU floating around?
And just remember, if you can't see John's screen well enough, go up to View Options on top of Zoom, and then you can choose a zoom ratio.
Yeah, I have XCTU in the middle of my screen. Can everybody see it?
We
Yes.
do.
Okay, good. Okay. Now, I have already done a task that you may have to do, and I'll tell you that it may take a bit of time, so be patient. I have this, you know, really great machine that was gifted to me by the cyber company that's a quad Xeon computer with 64 gigabytes of RAM, and this process still takes more time than I expected to, but I suspect it's the communications part. So you'll see this button here in XCTU. Well, let me do this. Let me start first. Let's say we don't have anything connected. So when you open XCTU, you will see this. Now, what you'll have purchased from Parallax is a USB module that you can plug your XBee module into, that you can then connect to your computer for configuring the XBee. I happen to have two of them, and they're both connected. So if you go to, you see this icon here with the search, that will scan the COM ports that you allow. Now, I happen to know that COM1 is my propeller and COM3 is an internal thing. So I'm going to select those, and then, oops, I don't want to do that. Next. And if you have a brand new XBee, if you know it's brand new, you can do just 9600, because what it's going to do is go through each of these baud rates and go out and ping the serial ports that you've allowed to see if there's an XBee there. In my case, I know for a fact that I've already got, well, you know what, I don't know that. I know they're not 115-200, so I'll do that. And when I do finish, you'll see this dialog now is going through, and it's pulling the serial ports, and there it is. It found my two XBee, so I'm going to add these to the system. Now, again, I've already reprogrammed these. Yours will probably say something different right here in the function if it's a brand new Series 3 module. If it's a Series 1, it will say something similar to that. Now, the way that you can get your Series 3 module to behave the way we want it to for the code we're going to be working with is with this update button. If you click this update button, it will let you select the code. I've got this already taken care of, but what you'll want to do is select this XBee 3-24 and the 802.15.4 TH. The TH is for through hole. The XBee Series 3 module is actually on the bottom of the circuit board. The top's completely flat. And if you look at that, there's a lot more pins on it than we get through the through hole. So this through hole knows what features we have available that are brought to the outside world. And of course, get the latest code. Now, I'm not going to do anything with this because it takes a while. But this will update the XBee with the firmware that runs the 802.15.4 protocol. All right. So again, be patient with that. It may take a bit of time.
And John, just to clarify, you chose XBee 802.15.4 TH, right? And just
Yes.
newest. Okay.
The newest, yes.
And this step you're going through, for some reason, people have a lot of trouble with this with XBee, the whole connect, discover, and then configure.
Yeah, once you've done it a couple of times, it all kind of makes sense. But I found that getting it to just the programming time, doing the downloading. I mean, it's quite a sophisticated module. I mean, like I said, the Series 3 now runs MicroPython, which is an interesting fact in and of itself. But we want to get it to this stage here, the XBee 3 802.15.4 tool, because that will work with all the code you found in other, like for example, there is a whole XBee book that Parallax produces. There's lots of stuff in there. I think it's primarily basic stamp. There may be some propeller code in there too. But that code will work with this configuration. Now there are features that are available with this module. So for example, these modules, this is new that you won't find in the Series 1 modules, the node identifier. I just left this stuff as is. In fact, if you ever have doubts about a module, as long as you have the right configuration, you can always click default and that will load all the default settings and then write it to the module. That will kind of get you to a base level. So I'll do that with both of my modules. So I know that they have the base 802.15.4 configuration that is loaded in the module.
And just to repeat that, John, because it bears repeating, default is all fine for what we're doing today, right?
Well, we're going to make small changes, but start there.
Okay.
And I saw in doing, internet reading, for the last couple of weeks, I saw 3 or 4 people say, look, before you're doing anything, it's best to reset to default, because there are ways. It says profile here. Once you have a configuration you like, you can save it out as a profile and then reload it into other modules. I mean, the lasertag company does that. There is a configuration for the lasertag, and in production, they get a fresh XBee module and they plug it into the programmer. They open up their configuration file and download it. But you really need to start with the default settings first, because not everything in the configuration, the configuration file doesn't update every single parameter. And so you may have some lagging bits that you don't expect. And I actually saw that in my experiments the other day. So we mentioned a minute ago, an easy thing to do with XBees is what's called transparent mode. In a manner of speaking, it's like replacing a wire. So if Kevin's still here, for example, perhaps Kevin makes a little remote controller that has a serial wire going out to his robot, so he can drive the robot around on a wire using serial back and forth between the robot and the remote control. Using transparent mode, he could very easily swap in, you could get rid of the physical wire and put in XBee modules on either side and get the same functionality. He's talking serial over the wire. We're going to be talking serial to the XBee modules. So going from the default settings, I should have, you see, it takes a bit of time to read it. It's not super fast. So I'm going to try to minimize my back and forth here. And I'm not going to do this today, but if you're going to do something with the XBees that you're deploying out, beyond your home, I suggest you change the channel and the PAN ID, because most people don't do this. And, it's kind of like with Bluetooth, change the entry code to something other than 1234, the pairing code. It's the same thing. I was joking around with myself, and because channel F is the one of those channels that doesn't hit you know, Wi-Fi hard. And so I did F for food and cafe for where you get it. These have to be hex. You can spell out cafe in valid hex words. You can do beef, do dead. That's not a nice one though. You can do dude, D-O-O-D. Have fun with leet. It's easy to remember that way too. Now with transparent mode, there is a parameter called AP, which is the application interface. So I'm gonna, I notice here is a little search box. And what you'll see in XCTU is all these little 2-letter bolded devices. These are the features and that we can change, and so you can search for them. So I know that AP is application mode, and it's already there. The default is transparent mode. Now, what I will typically do is change the baud rate to 57,600. Can go faster, but I have a question that into Digi that I have not heard back from. I can tell you though, one of the other reasons I think the propeller works so much better in the laser tag application than the PIC did is that at least the Series 1 modules, I don't know about the Series 3, but I suspect it is the same based on some information I read. Their baud rate is not precise. And, you know, for example, 57,600 in the XBee actually works out to, I think, 58 and some change. I have it in the listing so we can see it. So it's not precise. The great news for us is that we're using soft UARTs anyway, and we can set them to the imprecise baud rate of the XBee. Where you have with the PIC, I think it probably had a similar issue. Its baud rate generation wasn't perfect, and I think they were creating errors. So from the PIC version was only using 19.2K and still had occasional errors. I bumped the laser tag with the propeller up to 57,600 by setting it to what we knew was the actual value coming out. We never had communications errors. So this is a question on the Series 3, but I'll show you how I dealt with it with earlier models. And the final thing is, I was saying back here on, let me do this. In transparent mode, we have to have the same channel and pan ID for both devices. So that's a requirement. And they have to point at each other. So the address for the device we're dealing with is called MY, it's my address. The destination or the target is going to be this combination of DH and DL. This is destination high and destination low. For the way we're going to do things, we're going to use 16-bit addressing. So DH will always be 0. And anytime we want to use an address, we'll put a 16-bit value in DL. We'll see this more when we get to API mode. And then here is the AP setting is mode 0. Now, there's an interesting behavioral change in XCTU. If you're using a Series 1 module, it doesn't say transparent mode. It just says API disabled. It's the same thing. I don't know why they changed the verbiage for the module, but it is the same thing. It's the AP set, that is 0 for transparent mode. And again, this is for point to point, and there is a slight delay. Now, I make this point of saying point to point, but I'll tell you a true story. I was dealing with one of the original techs of the laser tag company, and he said, hey, can we do a really simplistic network using a master and multiple slave devices, but still using transparent mode? And some of you may remember in one of the sessions, Dennis Gately was referring to this little parser thing that I created called human-friendly control protocol. And it lets you type in strings that can be parsed on the other end that have values and commands and that. So he wanted to do that with these XBees. So we did a quick test. We had 3 or 4 slave XBees and we had a master XBee. We put the master as address 0, and then we put the slaves all as address 1. So they all had the same DL, or my address. They were all set to address 1. Here's the kicker though. the XBee actually has a 64-bit address that's unique. So this still worked. We were able to send a message to all of the devices, and then we had them, there was a little, on the boards we were using, there was a little dip switch, so we were able to set independent values into them, and we would say, send a message that was essentially, give me your dip switch value. And then, you know, instantaneously, we'd get a list of these 3 messages. Interestingly, the order that they came back was not always the same. And this speaks to the conflict resolution that's happening underneath. But we did all get those messages back. It's not the normal way to do things. If you're going to be doing point to multi-point, AP mode is really what is suggested. All right. So this guy is, oh, sorry, it's not set up, is it? I have to set my address and my destination. So I'm going to call this guy on top the address 0. So I'm going to leave my address at address 0, and I'm going to change the destination low to 1. And that's what I'm going to put in this device. So now I'm going to write these changes. So I have the things I have to remember. I'm in channel F, and cafe is my my pan ID. I changed the baud rate to 57600, and I'm address 0. The other guy, this guy, is going to be address 1. And now I'm going to write that. It's important you write that before you go off the screen, because you'll lose your changes.
John, could you please show where the baud rate was configured?
Oh yeah, I'm sorry. So that is parameter BD. So you can type BD here, and it'll take you right down there to it.
Thank you. And you said 57.6 is your choice?
I'm using 57.600. Yeah, that's what I've, you know, it's zippy enough that it's fine. I think once I have a discussion with the XBee guys, the Digi guys, about the Series 3 module, because I have a new, you know, oh, look here what's on my desk, a new lasertag board with a Series 3 module in it. You know, I'm going to talk to them about, you know, want to go to, you know, 115, 200 to find out what the actual baud rate is. All right, so now that we've done that, we'll just come over to this guy, which is also set to default, and make those changes. The difference between these 2 devices is going to be my address and the destination address. So again, channel F, cafe, baud rate, I want 57.600. It's kind of nice. I do like the way that this thing works. All you have to, you know, if you already have a setting in here and you just click in the box, it'll take you to it. And then AP is already set to transparent mode. And so we want my address is now, this lower device is address 1. And the destination is already set to address 0. Remember, destination, for when we're normally going to be dealing with 16-bit addressing, so DH will always be 0. We're going to put our address here. In the third project that we're going to look at today, we're going to set a full 16-bit address in here. All right, so we're going to write that.
And John, since many of us are working with one XBee USB adapter, you're fast on this.
Oh yeah, sorry. Yeah, I'm spoiled. I have a spare.
But the last changes you made with the 2 addresses, just repeat how you configured the 2 modules differently one more time.
All right. So one of your modules, the other thing you'll notice too, I don't know if this will show up, but can you see, I actually label my modules as well, so that I know what's going on with the labeler. That will be helpful, or blue tape. So this is one of the most useful tools on an electronics desk. So to put a label on it.
So I missed something earlier, I think, because I don't have the ability to change channel to anything. It's grayed out and it says 15. So I'm maybe in the wrong mode or something. I was trying to rig things up because I don't have a USB adapter, so I use a proc plug. I used a prop plug and I got it talking, and I'm talking to one of my modules, but I missed what you said at the beginning. So
do you have the function set? Can you see on the screen, Roy? Do you have the function set to XBee 3 802.1.15.4 TH?
No, it says Zigbee 3.
Okay, yeah.
That's the problem.
So we need to be 802.15.4. So this update button on the screen should let you set that. You'll have to find it and set it. But that's, you want the
Okay.
family. So this will take a bit of time. It's a bit of, because it's a firmware reflash. Once you have it in the 802.15.4 mode, then these features, all of these features, yeah, you're right. Zigbee's a whole different story.
Okay, that's the thing I missed. So it's doing that now. So I should be
Okay,
able to get it
fantastic.
configured.
Fantastic. So again, I will just, as a reminder to everybody, one of our modules we want to have set to address 0, and we want it to talk to, the DL for that module is going to be 1. So I'll go back and look at this.
So my is at 0, DH is 0, DL is 1 for the first module.
Yes, exactly. And then for the second module, my is 1, DH is still 0, and DL is 0. So device 1 is going to talk with device 0 and vice versa.
John Titus also put it in the chat, so I'll verify that too.
Oh, all right. Let me look real quick.
Yeah, he's right.
Can I see the chat? Oh, there we go.
And then do you set both of them to channel F and cafe?
Yes. So it's a critical point with XBees. For two XBees to be able to communicate with each other, they must be on the same channel and have the same PAN ID.
Okay, cool.
That's an that's a filtering mechanism that helps us.
It's gonna be a while. I'm still downloading the first module.
It takes a bit of time. Like I said, I have a really fast computer and it still took time. It's not the computer that's the problem. It's just the amount of downloading that's happening with the firmware flash. One of the improvements, we look at making with the laser tag is having multiple fields. And since we can change these parameters, as you'll see today, inside the software, from the propeller, we will have the ability to say, oh, you're on this field, you get this PAN ID. You're on that field, you get that PAN ID. And that will prevent RF messages from going from one field to the other. I mean, they'll just be ignored is what I should say. So I'll show you, since I have these things hooked up, I'll show a really quick demo before we get to the propeller code. Because again, this is a tool, XCTU. I'm pointing at the screen as if you can see my hand, sorry. And this here, this icon will open terminals. So right now, this XBee is selected. So I'm gonna say, open that terminal. I'm gonna connect to this XBee and open it. And now both are operating and they're in transparent mode. So I can say hello from 0, enter. Blue is transmitted information. So I typed ASCII in here. You can see the bytes that went out. Watch what happens when I click over to module 1. There's the packet that came from packet 0. Red means it's data that was received. And I can go back and I can say, this is number 1. And if I go back here, we see that was received. So this is transparent mode. Serial into one device is serial output on the other device. Like a wire with a little bit of a delay in there because there's that intermediate processing. So again, if you have a wired serial device, this is a really, really easy way to replace the wire. And I'll wait a bit so everybody catches up before we go to the spin code.
On that replacing a wire bit, we've used one of these to run our Haas, to serially feed our Haas CNC machine from a desktop.
Perfect. I have, what did I do with it? One of the things, I don't know if they make these or Ken, do you still carry these dongles, these XBee dongles?
We don't. They were not too popular because you could just plug an XBee unit into the XBee, the USB adapter we make.
I do like this though. I have a couple these things. So this is an XBee dongle. It's about the size of a flash drive that, you know, plugs into a USB port. And I use this for testing the laser tag projects.
Yeah, because you can use parallax serial terminal to communicate with another XBee
Yep.
when that's connected.
Exactly.
Hey, John.
Yes.
If you've got an XBee module that requires an antenna and just don't happen to have a plug-in or like a U.FL connector, does XBee care to be powered up without an antenna at all?
I've done it. It doesn't, I'm not it's been a long time since I did a lot of RF stuff when I was in the Air Force. I wouldn't do it for extended periods. If you do tests, you probably get away with it.
Thanks.
Mm-hmm. I tend to be overcautious with everything. I want to make sure, that way I can't complain at myself if something breaks. Now, sometimes I feel like I'm a little old lady with how cautious I am with things, but God bless the little old ladies. They know what they're doing. They've been around. So Ken, let me know when you think it's okay to move on to the propeller code. And let me say, the process you've seen, I'm going to show you what's happening in the propeller, and you don't have to run this code. You'll have it. You can run it at any time. I just want to talk about small things. Program 1 is called XBee Transparent. Now, here's that baud rate that I was telling you about, 58.8 is the actual baud rate. The reason I'm using that, and forgive me, I have both there. They'll probably both work, but so that I wouldn't have to unplug too many times my XBees, I have a couple of Series 1 modules right now plugged into my JonnyMac. And they're configured the way that we just did. So this is my XBee baud rate. Again, this is the actual XBee baud rate. And you'll see this, again, you do an internet search, people say, hey, I hooked up a scope to the XBee and that baud is out of whack. They have the actual baud rates buried somewhere in a piece of documentation that I wasn't able to find, but in my XBee object, I have the values that we would normally use with a P1.
And quick question on that, John. So up until now,
sure.
I've always used 9600 as the actual baud rate in whatever application, Blockly Proper or Basic Stamps or whatever, Arduino. Is that more of a true, will it sync to these baud rates if we use the correct ones, or will it not actually work? How tolerant is it?
Well, again, with the slower baud rate, you have more opportunity for, saving a wacky bit. The faster your baud rate is, the shorter your bits are. And if you have if you have an offset on the other side, it's problematic. Again, with the propeller, we have, very precise baud. Now, with again, this is my cautious nature. The original laser tag was using 19.2. So I quadrupled that and everything worked fine. Again, I'm using the baud rate that the XBee is using. So if you can do this, if in Blockly Net, you can set the baud rate to anything you want, you should be able to, because the serial code is a derivative of full duplex serial and should allow you to set the baud rate to any value. If you can, then you can match what the XBee is doing, and now you can run faster without worry. Now, since it's a full duplex system, and on the P1, I tend to run a little slower with external devices. I'm sure it would run 115, 200 without any problems. In fact, I have the constant for the actual baud rate built into my XBee object. But again, it's cautious nature.
Thank you.
Mm-hmm. So in this project, we have transmit and receive pins set up for 2 XBees, and I have them kind of on opposite ends of my JonnyMac just to keep the wiring kind of sorted out. So it's XBee, and this is TX and RX 0. So this is my XBee 0, and then it's my XBee number 1. We'll talk about this in a minute. This delay, this is in milliseconds. Now, what I did, because what Ray Roderick is doing with the formatting stuff is where I want to go to. So with the XBee, we're just sending packets. We don't need formatting or a lot of stuff. So FDS Minimal is a stripped down version of full duplex serial. So there's no formatting in there. It'll send a character, it'll send a string, it'll receive a character, and it can receive a string. I did add string reception to it per Ray's suggestion. So it's a stripped down thing. Ultimately, to be honest with you, I think I just want to use this all the time and then have an external formatting tool that will format anything that I can send as any serial object. Not quite there yet. So we're kind of in an imperfect state, but since this is going to get used inside the XBee object, I didn't want to burden the XBee object with all that other stuff because my current full duplex serial calls a formatting object as well that we don't need in XBee. This program has a couple of strings defined. This is going to be from XBee 0, and then this is going to be from XBee 1. I'll bit down. So here we're starting the object. So this looks like a full duplex serial start because it's based on that, just using the XBee baud rate. Again, using a constant, we can change that value up the top and not have any problem. The terminal is based on the stripped down version, so I don't have the T start in there. So this is why we have the full, all of the parameters. These things work. I did test this in PST, and forgive me, the Apple folks that are using, or the people that are using FlexSpin, I only tested one of the programs. I have every expectation they'll all work in the ANSI mode, but if you run into a glitch that you can't solve, let me know. All right, easy peasy. We've got everything started, and we'll let the terminal open. What we're going to do is send a string from XBee 0. Remember, it's linked to XBee 1. The TX flush will let that go out. And then we're going to wait just a bit. This is what I was telling you earlier. When I didn't have this delay, there was a delay, and I wasn't sure what was going on. And after a while, it occurred to me, okay, I'm sending a serial string into the device. The device has to packet it for the 802.15.4 messaging, send it over, and there could be some deliberations going on there depending on radio traffic. And then the second side has to receive it, take it apart, error check. If there was an error, it'll say, hey, give me that again. So there's a back and forth. This chip was indicating there's a lot of stuff going on underneath that we don't have to worry about. When we get serial out of the XBee, it has been my experience, it's good. And you really don't have to worry about it. So again, it's me in my, cautious mode that will check things, but most of the time, no worries. And then this is the case here. We're using transparent mode. We're just saying what goes in here comes out there, and it does. So by adding this delay, things will seem to work normally. This bit of code is a small loop that's just going through looking at XBee 1 until it runs out of characters. So what should have happened is that by the time we get here, XBee 1 has serial waiting in its, in its UART that it's sent out, and that we can actually pick up right here. And then we do the exact same thing, just the other way. So this is the most boring demo you have ever seen, but I'm going to run it anyway. So it's waiting for me to tell the terminal to run, and there it is. So the first line is a radio message going from XBee 0 to XBee 1. And the second line is XBee 1 replying back. The main loop has its own serial that is displaying all this. So it's kind of, I think the IT guys call it man in the middle. It's watching and commanding both sides. But the point is to show you what's going on. And that's that. So with transparent mode, it doesn't care what's going through the pipe. You get to control that. And here we're just doing plain text. This is why that guy, when I was telling you a moment ago, the guy wanted to use transparent mode with multiple external devices, because it was just plain text. It did work, but probably I would go with API mode, and I'm going to show you how to do that here shortly. Okay. Any questions? Again, this is the easiest mode, but it's useful. If you have a wire, as Ken pointed out, if you want to be able to control a gigantic CNC from a computer and you don't want to drag a wire around, you can hook up a couple of XBees. It's really simple.
John, question about the IO pin declarations in the program.
Yep.
People always get in trouble over this, including me right now. XBee RX1, these are from the XBee's perspective,
No,
right?
no, they're from the propeller's perspective.
So
Thank
XBee
you.
RX1
You know what?
is
I had reminded myself to talk about this. No, this is, you know, I may be wrong. I will let somebody buy me dinner and convince me I'm wrong, but it's going to cost you dinner. That if in a listing, I do from the propeller's point of view. You gonna fly up to LA, Ray, or do I have to?
No, you'll be on your own.
That's a long flight for either of us. I do things from the propeller's point of view. So this TX0 connects to the D-in line on the XBee. I should have put that in the notes. I apologize for not doing that. Oops.
You gave us a 50-50 chance, John.
You're right. No, you know, it's, you know, I'm not making it up. You talked to me yesterday when I was feeling like I'd been run over by a steamroller. But I reminded myself to talk about this and I skipped right past it. Yes. So this is the transmit one to the XBee. Because that
I figured it out because all your other examples are the same way.
Yeah, well, and that comes from precedent from the P1. The transmit pin out of the P1 is the lower value with the even number, and so I've just kept it that well. So and it's that way in the P2 as well.
And John, before you move on, maybe I could show this on my desktop for those who don't have the circuit.
You got it.
Okay, I'll do that now. You can grab some water.
Yeah, you can. Oh, here, I'll stop sharing.
I'll just take it away from you.
I gave
very
it to
nice.
you before you
Yeah.
take it.
I don't want to get you upset now, but
No, I'm in a better mood now.
okay.
No?
So this is how I set it up, and I think you want to scold me over the orange and yellow wire. This is your chance.
Well,
it's taken me a while to learn.
No, that's fine. In mine now, I don't know if this will show. Let me power down really quick.
I tried to follow the JonnyMac wire color scheme.
Well, so in mine, now we haven't done a lot of serial stuff, so maybe I haven't talked about this. The nice thing is now I have the breadboard based adapters that are the DIP module. So then I have the normal wires, and then I have extra shells. So what I did is I took 4 wires and then a 4-pin shell, and I made a nice, neat, it's 4 pins on this side, and it's individual pins on this side. The order on the 4-pin side is black and red. Those are power, ground, and 3.3 volts. Yellow is the D out, because that's going to the receive pin on the propeller, and then white. So looking at it,
I'm reversed.
Red, yellow, white. I use white for transmit and yellow for receive. Again, propeller centric.
White transmit, yellow receive. I just want to repeat that for Saul.
That's what I use.
Otherwise it won't work.
No, it will. If yours is working, you've just proved yourself wrong. But it is good to use different colors. Don't have one giant, I've seen people wire up breadboards with a single color, and I think, oh my goodness, if something goes wrong, we're in trouble.
And for those who don't know what the USB adapter looks like, it's this.
Oh, yes. Yeah. That's what we used for configuring. Although then clever people like Roy was, I got a prop plug. I can do it with that.
Okay, any questions on this circuit before I go back to John?
Yeah, this is John Titus. Can I grab in here?
Hi, John.
Sure.
Yeah, I just want to mention to people that you do not need a computer attached to an XBee module. It can work autonomously and do many things. And
John, you're stealing my thunder.
Oh, okay. I'll shut up. Bye.
I told you there was a surprise coming. And John is absolutely right. And I'm going to show a Hollywood project that takes advantage of that. Yeah, there are what John's talking about. They have, let's remember, there's processors built into these things, you know, and the Series 3 is clearly quite capable since it's running MicroPython or has the ability to run MicroPython. In fact, you can configure XBees to talk to each other and need no computational stuff at all. I saw a project a long time ago where somebody out in a rural area was fed up with walking a mile to their mailbox and finding no mail. So they figured out a way to put an XBee and a sensor in the mailbox. If the mailman came and did something, then they got a signal, you know, through one XBee. So you can, just like, you know, in this case with transparent mode, we're remoting data, but there are I/O pins on the XBee, including analog, that you can also remote. That's a topic that goes beyond today, but I am going to share a variation of that, you know, one of my Hollywood friends, you know, called on my help with XBee, and we did that. Yeah, they're as I was saying, we're covering about this much of a world that's this big, you know, with XBee. It's quite sophisticated. Okay, shall we move on?
Yes,
I
John.
just wanted to comment
John.
related to the world that's this big. When I was using the app earlier to try to find my XBees, my house is full of Zigbee devices.
Oh,
and it was
goodness.
like listing hundreds of them because all my light bulbs and smart devices.
Yes. Yeah. Yeah. And this, you know, this creates, you know, some challenges, I guess, for us. You know, the world is increasingly more wireless. Lots of stuff out there that we're contending with. I guess
how do we know if our light bulbs have Zigbee? Was that an intentional thing, or is that just what you get at Home Depot these days?
No, I have Philips Hue colored light bulbs, and they have Zigbee as part of their communication. And the reason I went with them is because they're Zigbee and not Wi-Fi. A lot of the other ones are Wi-Fi, and I was trying to avoid having too many Wi-Fi devices, so I went with a bunch of Zigbee devices.
Nice, I see. Okay.
Zigbee and Z-Wave, because I use a SmartThings hub that can do either.
Yeah, so John Titus, I hope you understand. I was being cheeky and teasing. I appreciated your input. I didn't mean to sound. If I sounded gruff, I didn't mean it.
No problem. Understood.
Okay. Yeah, but thank you for that. So now there's a second hit at, hey, there's a neat surprise coming with my friend Matt, who I mentioned frequently. But let's talk about, before we get there, let's talk about networking, if you will. I'll go ahead and reshare. Is it okay for me to share my screen again? Will it work?
Of course.
Okay, and then we'll go back to the presentation. So we talked about transparent mode. And the other thing we're going to talk about is API mode. This is what we're going to do most of the time, you know, 99% of the time probably. Now, devices that are working together in a network, again, must have a common channel and the same PAN ID. We're going to set their AP. We had 0, which was transparent mode. We're going to set the API mode to 1. There is a mode 2, and this I mentioned, I think, briefly earlier, that mode 2 allows you to replace bytes that are within your packet that may cause software to think, oh, geez, I have the start of a new packet with an escape sequence. I've never found that necessary. And again, you can do point-to-point or point-to-multiple with API mode. Now, an API packet is something we have to build to send to the XBee, and then it will deal with it after that. This is the structure of a packet I'm using in the little demo program, and I've used this for lots of little personal projects. It works like this. 7E is the packet header. The next 2 bytes, which are big endian, is the destination address. And we're using 16-bit mode. And that's actually what this frame type byte, this 01 indicates, is that we're doing a transmit frame with a 16-bit address. You can also do if you use a frame type of 0, your address is going to be 64 bits. 0 is a frame ID, which means we don't want to use an ID. This is, I may not be explaining this quite right, but if you're using some, if you want to get responses back to say, hey, did that message really go through? You can have a frame ID assigned to that so that you know that a particular frame made it through. As we've been talking about, I found them so reliable, I've never used it. These 2 bytes, again, big endian, are the destination that we want to speak to. So this is 5200 is the address. Now, the reason for this is, and these are all hex values, it's obvious, I'm sure, by the 7E and the 0A. 52 in hex is is R in ASCII, and so this is for remote. So I use this is my remote, and this is my base station, or my station of the remote. So that gives me 256 remotes I could have using this simple scheme. This is a secondary features list. If you do 1, there's no AX. Again, we don't need that extra traffic. The green area is my stuff. Okay, so this is a command 70. This happens to be get the time. And I use these fixed length packets just because I find them easier, and I use this successfully in the laser tag. And I'm going to allow my packets to carry 1 to 4 bytes. Now, in the laser tag, we actually have 3 packet types. The original laser tag had 2. In the original laser tag, basic commands like restart a game or, you're out, go home, used only 3 bytes here. What happened with the new version of the laser tag, the propeller base, the owner said, hey, we want more features. For example, one of the features that you can set inside the laser tag device is friendly fire. And so your teammates can hit you. But it's normally a setup thing that you have to configure before the game starts. They wanted to be able to enable or disable that during the middle of the game. And so we had to create a message structure that only the new taggers would understand and would be ignored by the old taggers. So we added 2 bytes to this message. And so we did that. Then the cloning packets have a different number of bytes. So when you're looking through XBee documentation, you'll hear the term payload. So I skipped right past it. These bytes are the length of the payload. And that's everything from here to here. So everything between the size of the payload and the checksum is the payload. Right, so there are ways, this is helpful seeing this, you'll see it's helpful on the reception and all the kind of checks that we can do to make sure we have a valid packet. So this is what we're going to build. Now I'll show you, first off, getting into in using the API mode. Oh, I guess I should configure an XBee to do this. So I'm going to grab this XBee and let me turn off the terminal. So you'll go through and back. So this guy was my base before. So this one that was 1, I'm going to reconfigure for and move it over to my propeller. So the thing that I have to do is change the mode to AP mode 1, no escape. So it's AP without escapes. I'm going to leave everything else the same. And now I actually don't care about the addressing because I can change those from the propeller. And I will write this to the device. And I'm going to turn it off. And hopefully I got the right one. Hang on one second. All right. So I'm putting the module, which is now an API mode, into my JonnyMac board, and I'm going to look at program 2. So this is this shows how to read configuration values and set them. And that now we get into using the XBee object. So this XBee API 1 is a bit of an overlay over this minimalized serial program. So here we're going to do the commands that allow us to get settings and put settings into the XBee. Here's that list of values I was telling you about. So as you can see, Ken, look, at 9600 baud, it's almost right on. So it's really close there. As you get out further, though, the wobble gets farther. So this is the theoretical baud rate. This is the actual baud rate. And again, I need to check this. I put that note in there because I need to check the Series 3 to see if they made improvements in the way they do baud rate generation. But with Series 1 or 2 modules, this is what I use. I have no troubles. So this object has its own kind of, it has its own sets of buffers. Now these are not the UART buffers, but these are the things we pull out of the buffer, the UART, so that we have them and we don't have our full duplex serial overload. There's a simple start method that will get us to 9600 since that's a default baud rate. I tend to use startx, which lets me set a specific baud rate. This is going to start this serial object, the FTS minimal. And now we get into the things, and I'll only go through a couple of these because it's going to be the same kind of thing. The first thing I want to do when I'm using this is check to see if I have a radio connected. And so what I'm going to do is send this AT command with this string, my. Remember, my is my address. And what this method is going to return is the value of that. If there is no response from the radio, we don't have one. Earlier I panicked because I wasn't getting a response, but I had missed a pin, so I just had a pin off. It will get -1. And so if we look to here, what's going on with the command? So the AT command is expecting a 2-byte string, and it's putting together an AT packet or an API packet like I just showed you. Now you'll notice that this is a fixed packet. We know that the length of the payload is going to be 4 bytes, and 8 is the packet type. This is an AT packet that is going to the processor of the XBee. This is not something that's getting transmitted out of the XBee. This is a command to the XBee. It's an AT command. And now, we're going to put those bytes there. We're going to do the checksum. The XBee checksum is really simplistic. You're going to add up all the bytes in your payload and take the low byte and subtract that from FF. That's coded in here, but it's really simplistic. And now I clear out anything that might have been left over in the receive buffer because I don't want stuff in there that creates a false answer. And I send that command, and then I let it go out. So that sends the command to the radio, and then we're going to use this method called getAtValue. And this is just as a reminder, this is returning a value, so we have to declare it. Remember, in the P2, unlike the P1, we have to declare return values. I tend to most of the time just call it result, which is the default name of the return value in the P1. So what happens now is I'm going to get a frame from the XBee, and I'm going to give it 25 milliseconds. Like I was saying earlier, there's a little bit of delay in there, so don't be too greedy with time. I found with these kind of commands, 25 milliseconds is plenty. And so this now is going to what I think is why we succeeded where the PIC guys didn't. This is my RX frame. So this is waiting for a frame and sending the raw data back that can be extracted with. So remember, if we look back at the presentation, an API packet starts with 7E. I want to point out something. With these API packets, our payload can only be 100 bytes. What that means is that, our custom data here. So the payload can be a little more than that. My point is this value is never going to go past FF. So this high byte is always going to be 0. This is why I think I didn't need the escaped mode, because if you look at the code, I'm doing those 2 checks. I have a mechanism for looking to see, I have a way of either waiting or not waiting for the byte. If the first byte is 7E, that could be the start of a packet. And then then we go through and get the others with just a little bit of delay in case we hit right on that. But you see, I'm putting this into my local buffer and going through. The nice thing is when we get to the payload LSB, which is a 3rd byte in that packet, I'm saving that value because that tells me how many more bytes are in this particular packet. This way, if packets stack up, I can deal with them individually. And this was really important for when we were getting that case where, hey, I'm going to shoot at 10 guns at the same time. Remember, all 10 of those XBees are sending data back. So all these packets are stacking up in the serial buffer, but I want to be able to pull them out and process them one at a time. And this is why I was able to do that without any problems. Because otherwise, there's no, since in that case, there was no gap between packets. It's just a big stack of bytes. That's how we did it. So that will, this will return a positive value if we have a good packet. Now that packet that came back from the device is in the buffer, and I gotta find, I wish there was a way to move the, oh, there is. Yay. Let me go to summary mode because I want to say so extract AT value is what pulls the value out of that AT response that we just got. And so, I won't go through all the details because I kind of don't remember them, but what I'm able to do is figure out how many bytes are in the response, because it could be a 1, 2, or 4 byte response. And then I know it's always going to start there in the string, and then this offset is for the result byte, because in the XBee, often values are big endian and we want things little endian. So this is what's going on here, is that it's grabbing the values out of the buff and it's putting them into the result backwards so that they're corrected when we get them. So this is what gives us values. And again, you can black box all this stuff. It works really well. But if, I'm sure somebody will see, oh, and so there's a change I should have made. That should have been, I tend to try to do that. This is code that was not a very big, there's not a big difference between the P1 version and the P2 version. It translated really nicely. So if we then look at this program, this P2 this version 2 program, what this is going to do is talk to the XBee and tell us about its parameters. So if I run this, and hopefully I pulled the right XBee out of the thing. I may not have. Hang on. Oops. I was trying to move too fast. So let me try that, because I only changed one of them to API mode. There we go. So this now is the parameters that we set up in XCTU, but I've read them directly from the propeller. And so you remember we set the channel to F. Cafe was our PAN ID. We didn't have a destination value. We had originally put in address 1 for that. And then this is the serial number that is unique in the XBee. So this is another thing that can be used in the system. In fact, the guy that wrote the game management system for the laser tag, he uses this a lot because of that situation Roy was talking about. You can have a situation where there's lots of XBees out there. And so he's communicating with the system and looking for certain things. And then he's logging everything, excuse me, by their serial number, because the serial number doesn't change in the module. We can change all this other stuff, but it doesn't. I added this from my P1 program. You may, if you read back that the API mode is mode 1, or mode 2 rather, then you have to handle things differently. But what we can do now is put this into this other program. So here is now a program that will use the XBee. This program is the remote side of a command and control thing. We're going to just send the command messages from the other XBee using XCTU. So we only have to do, we don't have to have 2 XBees hooked up to the propeller at the same time. One of the things that I like to do with this is structure the messages like this so that I can see what they are. Now, a lot of these values don't change, but the ones that do, I have put labels in so that I can use in the P1, I have to use byte move to update these things. But in the P2, I can actually use for here, I could actually use word move, and here I could use long move. It would work fine because of the way that the addressing works. But anyway, so I will use a DAT section to create my template message, and then I will populate this and then send it out. So if we look at this, I just want to point out something. In this particular thing, my base station, which I have to configure here in a minute, is going to be, this is going to be my 16-bit address, you know, BA5E for base. And then here is going to be my address. It's just going to end up to be this 5200 for the thing. But here is 52 is, you know, for R for remote. And then this is my station number. Here's my ID. So this is my ID. This is going to be programmed into the XBee. And I can show you that. So if I run this, I guess I have to turn things back on. I have propeller tools set so that it doesn't it doesn't disconnect, just to make it a little easier. So F10, 12. So you notice, so this says configuring radio. What that did in this particular program is it checks the radio to see if it's there, and then it looks at its address. If it's not set to 5200, which is what this program calls for, it configures it, and that's what that was. And that says, okay, I'm ready, send me some packets. And now we can go back to the other program that was this reader and run it again, and we'll go F10, F12. And now you can see that the address has been changed. So that happened from the propeller using a feature in that XBee module. So here I have this method called set my address. So inside the XBee object, there is a method called set and verify, and then you're going to pass it the string. Remember all those 2-letter strings that were in XCTU. So you're going to just pass it the string, pass it the value, and how many bytes are in that value. We're using a 16-bit address, so we send it 2 bytes. And set and verify will give you a value true if everything worked out. If you had a problem, like there was no device there, you could call this without checking for the radio, of course. And if you ended up having a problem, you'd get a false back. So it didn't work. So again, lots of redundancy, but we use this. Most of this code that I'm sharing with you is what I developed for working with the laser tag stuff, and it's all worked very, very reliably. And that's obviously key in a commercial product. To some, it may seem overwrought, and I agree with that to a point, but I just wanted it to work all the time, no matter the conditions, and it seems to. Okay, now I'm going a little faster through this. Again, some of this is black boxed stuff, because what I want to get to is the packets. You remember I showed you over here, here was a message, and at some point we have to create this. Now this is my structural idea. This is what I'm doing in this program, is that I have a command and I can send up to 4 bytes with it. Don't have to use them all. I am going to always have a consistent length packet though. That helps me check things, because when I get a packet in from that receive method, it tells me how long the packet is, and I can tell if the packet is correct based on that, or functionally what it is supposed to do. Again, in the laser tag, the original laser tag had a packet that was 2 bytes shorter than the new laser tag. So the new laser tag could respond to both. The old laser tag could only respond to the old packets. All right, so let's go back to XCTU. Because now what I want to do is I'm gonna just refresh this, because I was plugging and unplugging simultaneously. I pulled a Ken. Ken and I were talking once. He said, "Yeah, I just plug in, unplug and plug the XBees anytime I want. I don't worry about it." And I was thinking, "Oh my God, you do that?" Then I just did. All right, so add selected device. Yes. All right. So again, with this module, we want to set it to match the other one, which is API mode. All right, so we have, this is already correct. Just leave that alone. Now, my is important here because the base station has to have a specific address. So we're going to change this to BA5E for base. We don't care about that. I'm going to just change it to be persnickety. And then the AP mode is going to be mode 1. Everything else is the same. A really simple setup. So it's AP mode. And because there are features in the program that we're about to go through a little more, it will only accept messages from a specific address, which comes along in the packet. We have to set that here. We can't just do that willy-nilly. It's got to be a specific address, and that's what this is right there. And so my address. And now I'm going to write that to the thing. Now, I went through this diagram a couple of times. We're looking at this, and the panic sets in. You think, oh my goodness, how do I figure out this all out? And then I have to manually, well, no, you don't. One of the neat things about XCTU, it's got an enormous tool chest built into it. One of those is a frames generator. So we can use this to put together our frames. Now, if we go back to the code, I've made 6 commands that I want this node to respond to. Oh, this is where, with this program, if you have an encoder to hook up, then you can see that in operation. So I have a read digital command, and I'm going to pass along a pin number. I have a write digital command, that I can set high or low. So I'm going to pass the pin and a value, either 0 or 1. I can read the encoder. This is kind of a specific thing, or I can write the encoder. In this case, I'm going to reset it. And then in this program, I have a little background thing. And Chip is going to look at me and say, what are you doing? You fought and fought and fought for get MS. Now you're doing that. But one of the things that I do frequently in programs is I create a little background cog like this that runs on a 1 millisecond interval. And because you can do an enormous amount of work in 1 millisecond, especially on the P2. What this gives me, though, is this timer called millis that's resettable because it's a global value. And I do other things. For example, if I want to create a timer with it, I will set millis to a negative value and then wait for it to hit 0. If it's 0 or higher, I know it's expired. I don't have to, you know, once it's set, I don't have to worry about what the value is or was, just 0 or higher. So that's a way to do this. So all I'm doing in this particular case is I'm starting up this spin cog and incrementing millis every millisecond. And that gives us something to look at here. So here is.
Hey, John.
Yeah.
I'm thinking, you know, if you used get MS for get milliseconds and then put a target of something ahead, you could then check. You could always use get milliseconds minus your offset and see if it's negative or positive.
Yeah, I do that all the time. You're right. So for differential timing, it's perfect. In this particular case, I wanted to be able to have it settable. And obviously there's no right MS, which, you know, for good reason. Although you can figure out a way to do that, that'd be good.
There's also this pole count instruction, which will do kind of the same thing.
Oh, okay.
I'm just thinking if you ever got in a pinch and didn't want to use the whole cog for that, there are lots of
no. And I almost never do. Now this in the P1, I always had to do this. In the P2, I was just doing this for this particular demonstration. So we didn't, because I was thinking, well, we could hook up the real-time clock, but I'm trying to minimize hardware because our focus obviously is on the XBee. But this just gives us a value to change. Although we're doing it in 2 cases. We're doing it with this and we're doing it with the encoder because the commands allow us to reset the encoder. So we have, again, the commands that this little remote module will accept are a digital read, a digital write. Those are going to both require a PIN number and it's legal. And then also the write requires a value. And then we have the ability to read the encoder, we have the ability to reset the encoder, and then we can read that milliseconds counter and we can reset that milliseconds counter. So those are the things that we can do. Now we have to build those packets. We have to build packets that look like this for all of those things. This is where XCTU helps us initially, especially for checking. And again, I keep going back to the laser tag thing because it was a 2-year project and a big bulk of the time was dealing with XBee stuff and making it really reliable. So I was frequently, anytime the owner would say, hey, I got an idea for a new feature, I would always test it through XCTU to make sure it was doing what we wanted it to do before I started implementing, you know, stuff too deeply in the propeller, because that was a lot of code and it was pretty tightly wound. So here we go. What we want to do is start with selecting our protocol, which is 802.15.4. And we want to do API 1. So it was already set. The transmit type for us, remember I told you there's 2 transmit things. We can do a 64-bit address. We want to use a 16-bit address. If it's a 64-bit address, we have to know that serial number from the device we're talking to. It works out easier. So you can see here's some of the things in the pack that we can't change. This frame type corresponds to that. The frame ID we don't care about, so we're going to get rid of that. And now this is critical. This is our destination address. This is 5200. That's our remote. It's remote number 0. We don't, in our options, we want to disable the ACK. We don't need that. And now here is our packet. So the first packet that we're going to build, if we look over here, is the read digital. I have to get the hex value. I forgot what it was. Okay, D0 is the read digital. And we're going to set we have to send the pin number as well. I have my encoder hooked up to pins 40, 41, and 42. So the encoder button is on pin 42. So that's what I'm going to use in my command. Now, everything has to be done in hex in XCTU. So 42 is hex 2A. So here I'm selecting hex, and I'm going to say D0 because that's my digital read command. The first byte after the command is the pin number, so that's going to be 2A. And then I just need to pad this out with the other 3 bytes because that has to be a 5-byte packet. So there's a couple of things I can look at. I know my packet is 14 bytes, so that's correct. And I know my payload is 0A, so that's correct. So this is all kind of good. What I'm gonna do is I'm gonna copy this, and I'll leave that open, and then go over to another tool where we can do the serial console. So this allows me to connect to this device and send packets. Now here's where the packets are built in. So I'm going to add a packet, and this is going to be, I'm going to just call this read encoder. Oh, encoder button, and go here and then paste this in. So now when I add the packet, we can run the program, and I'll do this, we'll do this incrementally. So if I run this program, F10, F12, and notice it just says ready for packets because the address was already set. It didn't have to reset the address, so it was ready to go. And now we come back to XCTU and say run this packet. We should see on the other side, things went well. This worked earlier. Oh, there we go. So here was, I have the debugging capability for this remote module turned on, so it'll spit out stuff to PST. And so here's the size of my packet, and here it is. And then it interprets it for me. It says, okay, read pin 42. Well, that happens to be 1 because I wasn't pressing the switch. Remember, the encoder has pull-ups on the buttons and the encoder inputs. So if I press and hold, I'm pressing and holding the encoder button, and I do that again and then go back. Now it's 0. That'll make sense? And there's another, forgive me, there's another version of this that is actually better. Let me look, because it shows the transmit and receive packets. Hang on one second, let me see where I got to it. Again, there's a lot of tools inside. Oh, maybe it was just this version. Yeah, here it is. So I'll do that again. If you go directly to the terminal, if I here and do this, it says, gives you the ability to call this object. So we'll just make this really quickly. Read ENC button. If I click here, it's going to bring this up. 804 API 1 mode 1. I'm not going to do this for every command because I've already saved them. I'll show you how to do that. Frame ID is 0. 5200. No X. Hex is D0. 2A. 00000. And everything should be hunky-dory. And we go back and notice how there's a little thing that says, hey, that's a good API frame. Well, it should be because it was created by their tool. And then we can add it in. And now when I connect and select over here, we see that I screwed up. The good news is I can edit this. It says the command was 30. Oh, that was a typo on my part. Why didn't anybody catch me? It's D0. Okay, apply changes, send again, and now we get the encoder input. So what I did earlier is I went through and I created a bunch of these packets like this. I can do another if anybody wants me to go through it again. It's a tiny bit tedious, but this is useful to know how to do. It's been dangerously quiet today. I'm afraid I've lost a lot of people.
Hey,
Let's
this
get
is
some.
John Titus. Can I jump in here?
Yes, sir.
Okay. I just want to mention that, can I share screen too? Yeah, I guess I can. You cannot, well, other participants are sharing. You have to
go ahead, John.
unshare. Okay. Okay, well, that isn't quite what I wanted to do anyway, but let's see, I'll get out of here. Don't share screen right now. Texas Instruments makes this little device. It is a packet sniffer, and it's the type of device that you can use with the Texas Instruments software, and you can actually see the information that's going back and forth between the modules. And I used this a lot when I was developing products and things with XBee Series 1 and Series 2 devices. And I'll post this in the chat section, but it's called the CC, like Charlie 2531 evaluation module kit. And it comes in a nice box, and there's software from TI. Now let me go ahead and share my screen. And all right, share. All right, this is the kind of information that you're going to see. It's got all of the information on here from the, this happens to be Zigbee, but it'll do it for 802.15.4.2. And you can see exactly what's being transmitted in one direction and exactly what's coming back. So it's a good troubleshooting tool, particularly if you've got more than just back and forth between two modules. It's a nice tool. And now I'm going to do, let's see, how do I get out of here? Screen sharing.
Bottom of the window.
Bottom of the window. Okay, I'm just looking at my own window here. I'm not particularly swift with this. Stop sharing. Okay. All right, some self-promotion here. A couple of years ago, I wrote this book. It's called the Hands-on XBee Lab Manual, and it's got 22.
Well, why aren't you teaching today, John? I didn't have to go through the last week.
Yeah, this has got 22 experiments or exercises in it, and I urge you to go look at Amazon, and you can look in the index and see the different things that are available. Now, I don't get any royalties from this book sale anymore. So, you know, it's not going to benefit me at all. A charity gets them over in the UK where the publisher is. I said, I don't want royalties anymore. Give them to somebody else. So that's what they did. But I think it's still pretty good. It was written in 2012. So some of the XCTU screens are a little bit different, but it goes all the way from just what John was talking about, sending messages back and forth to networks and so on. It does not cover ZigBee. It's just 802.15.4. So, okay, I said my piece.
Thanks, John.
Yeah, just wanted to share.
Yeah, John,
that.
if I'd have known about your book, you know, if I did a camera pan, which I won't, you'd see books everywhere. I love books. So I'll go order it as soon as we're done today. Because books are good.
The reviews are good. There are a couple of people who couldn't figure out how to use the newer version of XCTU. The software is all in C. It was written at the time for the Arduino and also for the Mbed ARM processor, but the C code is C code. You can transport it pretty quickly.
I've translated thousands of lines of C to spin and probably will translate some of your code.
All right. Got to go to dinner, guys. I
All
really appreciate it. This is good tutorial information.
Thanks, John. All right. Okay. So let's build one more packet, and then I'll show you that when you're going through this exercise, let me make this point. If you're doing your custom thing, which I hope you will, and if I didn't say earlier, as John points out, there's a lot of stuff to this. XBee is not one of those things where you listen to me or you listen to John or, and okay, that's it. I'm done. Let's go. It will take a little bit. There's just a big volume of information. So give yourself time. I'm hoping today between what I'm sharing, what John has shared, what others will share, is that when you're going back through the code, you're looking at my code or looking at John's code or looking at other XBee code, things will you'll remember, oh yeah, this was that part of the discussion. This is why that's happening. So I hope it's helpful. So we'll build one more packet, or we'll build a couple, I guess. So let's do we're gonna add a packet. Now, remember, another thing that we have is the ability to set a digital output. So I'm gonna, since all of our if you're using an eval board, like this, we have LEDs on there. We also have 2 LEDs on the edge. So I'm going to call this LED 56 equals 0. Now I'm doing this because the polarity is different from eval to edge. So this is just writing that value to the pin. On the edge, it will turn the LED off. On the eval, it will turn the LED on. And again, 16-bit address, no frame ID. I wish it would retain all the last values, but it doesn't. And this is D1. Now, in our case, I'm using pin 56, so that's hex 38. And I want, the next byte is, the low bit of the next byte is the status of that pin that we're changing. So that's going to be 0. And then I have to pad out 2 more bytes. And so this, again, we have our proper payload length, proper packet, save this, and add that frame. And then we'll just do one more. And this is going to be LED 56 equals 1. Again, yeah, 16-bit, no frame ID, 5200, no AX. Hex is going to be D1, 38 hex, and then this is going to be 01, 0000. Pad out that frame. And then add frame. And away we go. So in my case, I don't know why, and maybe Chip can answer this. My LEDs on my edge always default to being on no matter what I do. I have to physically turn them off. Are there pull-ups somewhere that it's having to overcome?
They're just high impedance CMOS. They float around.
Okay,
So
all right.
the weakest bias for any reason will make them go one way or another.
Okay, all right. So now if I select this packet and I send it, you can't see it, but I promise you my LED just went off, and you can see over here it says, we got that command, and I can turn it back on with this. So here was the case again with the laser tag, because that was a big project. We were creating all these new features, and I wanted to be able to test them cleanly. So I did this. I built a list like this. You'll notice that there's little save and open icons here. So you can build up a list of your messages that you want to test with, and then you can save them out. Now I did that earlier, so I'm going to open that up. And this is an XML file. So here's all of the messages that I created for this code. I suppose I should save everybody some heartache by including this. I didn't, but I will. It's just an XML file that you can read in. And now we can do things. For example, if I say read the encoder hasn't been moved since we ran it. So if I now spin it a couple of times, which I'm doing, and then ask to read it again, you'll see that the value changed. There is a reset encoder value, and you see that message came through here. And if I read the encoder again, away we go. Did I not do that? Read encoder. Oh, maybe I didn't reset it. There we go. And read encoder. Okay, clearly I broke something between 2 hours ago and when I started because this was working. So I'll fix this before I post. I'll repost the code. But I think you get the idea. This is a very simple approach, creating a fixed format message. I have found it very useful. And now in the laser tag, you know, as I was saying earlier, when I had a very big, not a very big packet, but big relative to everything else, I would take these packet bytes and I would add my own CRC to the end of that. So when I got this packet back, the clone packet from the XBee, I would pull out these bytes and then verify my internal packet with the internal CRC. And we never had any problems. We never bricked a device by doing an RF clone. It worked really nicely, and hopefully things will get better. So finally, because this has been a bit of a tough day, I'll show you another one of my fun Hollywood friend projects. And this gets to what John was speaking about. I have a friend named Ed who's a musician and a filmmaker who has a company called Midnight Syndicate. So if you like gothic kind of music that's Halloween themed, you know, look up Midnight Syndicate. He does really, really nice music. And he does occasional films and lots of live performances. So he consulted my friend Matt, who did the Stranger Things wall. We talked about that last time, to build this prop. This is a ghost hunter. So the idea behind this is when there's spirits in the air, you know, we get all kinds of throbbing lights, and this is a Scott Edwards OLED kind of display. So Matt did some really neat animations there. Now in the film, which is a short film that accompanied the live performance, the actor does this thing with tuning, which is what causes the behavior that they desired on set here. And there's a button that handles well. So the actor is manipulating these controls here. Well, when it came to the stage show, they then wanted to stick this thing out on a pedestal in the middle of the audience and just have it there, and then they had audio effects and that, and then they wanted this thing to come to life. So they needed a way to remote this potentiometer and this button. Now, we were going to build a full propeller-based remote, but doing some research and what John just indicated, there is a mechanism called Remote AT that lets you read the digital and analog inputs from an XBee just on its own. So in this box is nothing but an XBee, a potentiometer, a button, and batteries. And what we're able to do, the code is boring with all of that, but by sending this special Remote AT command, we get a packet back that then we have to go through and get here. Now here's my debug screen from that project. So you can see there's a lot of stuff coming back, and including the 64-bit ID, that's part of the packet. Now we're able to request it. You can see I was using my same strategy of remote 0 and remote 1. And in fact, that particular prop, because we didn't want things to go wrong during the stage show, we had 2 remotes. And what was going on is that the stagehand would turn on a remote because the prop, this guy, was constantly scanning the device to see if it was there. If it wasn't, then it would just use the local settings, which had kind of a neutral, you know, effect on the prop. But as soon as they wanted something to happen, the stagehand would flip a switch, this is the power switch here, and then press a button and turn the knob, and then that information would be fed back to the propeller, which was then animating the display and the lights. But you can see it's a biggish packet. And so, you know, we're bringing back digital information and analog information. So this is an advanced bit in XCTU, but you can go through and you can configure the IO pins on the device to do different things. You'll see in the default mode, for example, in the default behavior is one of the pins gets used as a clear to send indicator. You can also have a request to send line in. It's not normally defined, but you can define that. There are other things. So it's a bit of work, but it worked really nicely because you can see we were using a high power XBee with an antenna. Matt and his kids did a test, and he found he was able to control this thing from more than a mile away. And he figured, okay, in a big amphitheater, that's plenty of space, especially since it was line of sight. But you know, this gives rise to neat projects where if you need a headless, or you could live with a headless remote, or you don't need a display or anything, you can build that out of an XBee and then have your propeller get that data, the digital and analog data, right out of the XBee and use that to run the device. Now, in this case, it's a movie and stage prop. You know, I expect in 2 days, Kevin's going to show us how he's controlling a robot with an XBee doing this. Because that's the kind of things that you can do. So that's all for me today. It took longer than I hoped, but I hope that some of it sticks and you have fun with XBees when you start playing them.
John, let's see if anyone has any questions.
Okay.
Yeah, they're very quiet tonight.
I was so good it just stuck. Nobody.
No question, just comment that it was a good presentation showing all the cool stuff that you can do with XBee, or at least some of it.
Well, yeah, no, yeah. And thank you for the compliment. And yes, just some of it. I mean, there's so much more. So I didn't realize until, you know, recently, because I hadn't played with the Series 3, that it has MicroPython in it. And I'm thinking, okay, what kind of things can you do with that? It has Bluetooth built in as well, the Series 3.
Yeah, well, the I/O pins, like you can, it's a microcontroller, like you were saying at the beginning. So you can, now with MicroPython, you can program the I/O pins to do stuff all
Well, that's what I'm wondering
computer.
is, yeah, how much of that can we, how much of the MicroPython I/O library is supported? Because that again, that lends itself to some interesting things where you have a processor like the propeller on one end and an XBee that's just programmed on its own on the other for doing remote things.
Here's an example of an XBee
Oh.
use. This is a user on the Propeller One. He hasn't been there for a while. Paul K is what he went by. He did this as a Kickstarter project. This is actually a Propeller One with a XBee Pro in it, with a series 4 different joysticks, cots, toggles, and switches, or just.
I have that too.
I use this on my robot.
Yeah, he very kindly sent me one of his early prototypes because he had used a lot of my code. So I have it on the shelf because I saw that and I said, wait a minute, I have one of those. It's sitting over.
Yeah, it works really nicely. I use it on my big hexapod.
Neat. It is, I will say, I'm repeating myself a bit, but I think it's worth repeating. It can be a little intimidating at first, but once you dig in and then start to look at, working code examples, mine and others, you'll see that it's not too bad. And then, as always, I have this list of things as I think through the problem. Now, I tend to simplify, grossly perhaps. And, in my case, I really like to use fixed length messages. That lets me do error checking very, very simply. Now, I'm not always using every byte and every message, but it's a very small price to pay for the simplicity that goes along with it. And, sorry, I'm talking to my friend, but he builds beautiful props. This was designed to look like it was probably made in the 60s. So those that are my age and Bob's age and, few that are close to that, you see, you don't see these Dymo labels very often anymore, but they were a big deal way back when. That's what we used to label cabinets. Yeah, so there's, boxes, some 3D printing. These are WS2812s. Inside here is a Propeller One board called the HC8, which I'm often waving around, one of these dudes that EFX Tech makes that I designed for them. Matt uses them in a lot of his projects. So you can see these are prop antennas, and you can see the actual XBee antenna back here. It was neat. Turned out really well. He was justifiably proud of it, and Ed and his team they loved it, and I think I don't know, it's got a great retro look. I'd love to have that on my shelf.
Hey, John, on your first program you showed, were you using AX or no AX? Would you use the XCT software to set them up for transparent mode?
Well, let me look. On transparent mode, a lot of that stuff's irrelevant. So I'm going to go, since we're done with that part of the presentation, I'm going to redefault this dude. Where were you seeing that, Brian?
I think you saw that under the escape seat.
Well, yeah, so in transparent mode, we're not doing anything with the packets. We're using the default mode. If you look, in fact, if you look in the transparent program, there's no packet information here, and there's no, excuse me, there's no XBee object. We're just using plain serial objects. 2 of them for XBee, and 1 of them is going out to the terminal. And we're just sending, it's a straight through connection with a little bit of a delay in the middle because of that processing of converting our serial stream into the 802.15.4 message that's going out, and then undoing it on the other end and spitting it out. A little bit of a delay there. But otherwise, there's nothing to it. We're just using the default settings. Again, the only critical thing with the transparent mode is that you have to be on the same channel with the same PAN ID, and always set DH to 0. The DL on one device has to be the same as MY on the other device. That's the key. And then they're linked.
John, I'll show you how I'm going to apply what I've learned.
Okay.
Yeah.
Stop sharing.
30 seconds. Yeah, I'll just do this really quickly. This is a project I left off with Blockly Prop, but it's a robotic boat. I'm sure you've seen it before.
Yeah.
It's like 3 feet long and has some LiPo batteries and some Blue Robotics thruster motors in it. Anyway, I have an RC control, and what I finished with I wrote the code in Blockly, and I used the transparent mode. And I was trying to make a backup system so I could identify the location of the craft, and I used the 900 XPs, and it's a GPS transmitter receiver. And then I sent to the unit that I kept on the shore. And I left that boat and I drove 4 miles away, and I still got the data: latitude, longitude, speed, elevation, everything.
Nice.
Yeah, and I just I ran into the wall with Blockly Prop, really. But I'm going to pick that up again. So thanks for sharing.
Sure. Yeah, the XBee radios they have really good, even the series ones, what I do is like the series ones that we use in the laser tag, the original laser tag, that little tiny wire antenna, they had huge range. In fact, we ran into some issues in Europe because they have different requirements. So we had to have a different set of firmware for Europe. Because one of the things that I didn't cover, but you'll see as you explore XCTU, is you can change the power. There's 5 power levels in the 802. That protocol. So in fact, that's one of the features of the tagger, is that during the configuration, you can configure the power level. So if you're doing a small indoor game, we tend to use lower power because there's things are going to be bouncing around anyway. But if you're doing a big outdoor event in the forest, then we go to high power, and that's configurable through the tagger because you can set it as a parameter. As I showed in that one demonstration program where it changes the address. And I'm only showing how to change the address, but that functionality is how everything works. So those are simple demos. But the nice thing is, because of the way the AT interface works, it's very easy. As long as you can talk to the device, when it's in that API 1 mode, you can configure any of those parameters that you saw on XCTU. You can change through the serial connection with the propeller. Again, in the laser tag, we only changed the address and the power. So in the laser tag, when the device powers up, it looks at the tagger address and it sets that into the radio. That's how we can get a message to us, because when we hit somebody, our address is in that packet. Well, as you saw where we were transmitting to a specific address, we would put that into the destination low, and that would go right to that tagger. It's simple and very effective. And that way in the gameplay, you know, when you're shooting at somebody and you know, when you get that voice back, and they use the kind of an aggressive male voice, goes, good hit, that's a kill, you know, that kind of stuff. It gets people very excited. So there's lots of fun propeller stuff in that laser tag. There's audio and IR and all the things that people, it's very funny. Somebody at the beginning of that project, somebody kind of looking over his shoulder said, hey, why don't you just use an Arduino? It'd be so much easier. And I said, okay, let's have a chat. And then I said, you know, Arduino is nice, but can it do this? No. Can it do that? No. Well, then buzz off.
Can it send and receive to itself like we were doing today?
Well, that was the thing, you know, and you know, well, in fact, one of the problems with the PIC-based version of the laser tag is that it used an interrupt to handle the IR coming in. So if you were in the middle of sending your own shot and somebody's shot came in, it got blown up. So you couldn't shoot and be shot at the same time, but then the propeller one you can, because they're two cogs doing those processes independently.
Well, John, I'm thinking I'll take your content and all this great code, package it up with some screenshots for a quick bite so people can replicate the setup.
Okay.
If that would be helpful.
What I'll do is I'll just troubleshoot what's going on with that. I promise, hand to heart, I tested all those features and I don't know what I broke along the way. I probably just trying to make something a little prettier. But what I'll do, Ken, is I'll just check that remote control program, get that's all working, and then I'll repackage it and put it on the forums and send it to you. And I'll also send the XML file so that you don't have to build. You don't have to do what we were doing. You don't have to build your own packets. You can just open that up in XCTU and send the packets. Now the idea too, I think this is understood, but just to be clear, what you ultimately have to do though is once you've decided on your packets, then put that into your application. But XCTU makes a really great quick test tool where you can go and refine things and then go put them into the application.
I think there's a fair amount of XBee experience out there among the people here on the forum too.
I think so. It's kind of a quiet thing, but then, you know, you look at what some of us have done, and, you know, here, John wrote a whole book. I wish I'd have known about that. I'd owned the book by now. But you know, there is out there, and it's finding interesting projects.